Alright, so I decided to try and implement a JSON parser in C, and today we are going to start with the Lexer, and yeah, hopefully we are gonna finish it because I mean I did a Lexer in the past and I already know how it should work, so maybe we'll be able to go faster to it, like because of practicing my opinion, I think I should be a bit faster at doing it, even though it's been like a few months since then. But let's do JSON C, and the goal I would say with this project would be to be able to read the JSON file, obviously, and probably formatting the JSON in a nicer way, the same way like JQ works. I don't even have JQ installed, but yeah, if you know JQ, that one is used to I mean it can also be used to do queries on the JSON, so maybe we can also do that. That could also be another goal, like an optional objective, let's say, for our JSON parser. But yeah, the main goal I would say it's gonna be being able to read the JSON file, tokenize it, probably build that AST of the JSON, like the object structure with arrays and all of that, and then probably you know, serialize the JSON into a nicer format. But yeah, that sounds also interesting, being able to retrieve the keys same way as JQ with a really simple query language. But and also for being able to read from a file and have some data structures already implemented, I'll be using ds.h, which is like a header only library that I created. I guess, like last video, it was me adding the hash map implementation to this library, so should be pretty straightforward what it's about. But yeah, it has like custom orientations for dynamic arrays, hash map, reading from files. So yeah, even for allocators, if you're using this on embedded, I mean, I don't know if it's gonna work. I haven't tried it yet. It still has some bugs, like I have these if not defined stuff for standard library, like here, but I still have to fix some of the functions that are being used, like sorting arrays currently doesn't work without standard library, so stuff like that. Okay, so let's strange. Okay, so we have this ds.h file now, and we can even create our main.c file. So I would say include ds.h. We don't even have to define anything, and we can just use this to do hello world. It's something like that. And maybe having a make file, it's gonna be easier. So build is gonna be gcc main.c, and then we can have phony clean, I guess something like that. So we can just do make and then main, and it seems to be working fine. Okay, so how is our Lexer going to work? First, I guess we should do an example. example.json. Let's say, let's use the name. Wait, is it the same example as I was doing in the hash map? Kind of. Properties. Let's have John have some properties. I mean, age could be a property. Ah, no. Skills. I don't know. Like we can do fast. Fast. Oh my god. I wanted to say fast. And some other ideas. I don't know. Because I wanted to have an array, right? So fast and smart or something. I don't know how they are skills, but it is what it is. And maybe what else can you have in this stuff? I was gonna say something dumb, but let's do. I want to do something that's gonna be null, maybe. If we are gonna do the null object, so what can be null? I guess something named null, or I don't know. And maybe even let's do also escaped characters, like an escaped string, right? That's gonna be interesting to parse because JSON allows you to have this kind of strings, and maybe the number can actually be, I mean, I cannot do negative age, that's even wrong for me, but let's do like negative float. Why not? That's also a good thing to parse, and I think like these are all the important parts from JSON. Like sure, having strings, numbers, nested objects. I mean, sure, you can also have like an array like that, or I'm pretty sure even like this thing is a valid JSON, but okay, like we have a nested object, we have an array. I think that arrays don't even care what you have inside of them. Like you can have numbers, but yeah, and also the null object. That's wait, undefined. No. Yeah, I mean undefined would be missing pretty much. Like if you have, I don't know, the I don't know property and it's undefined, in JavaScript it would actually be just not there. So that's how you make the difference between null and undefined. I guess for null you actually specify null, and undefined it's just not existing. Okay, so let's say we have these things, right? So we would like to be able to, well, DSIO implementation, it would be nice to, let's do argc and sharp pointer argv. So it would be nice to read the file, maybe from the arguments. So let's do ds arg parser. Let's say is whatever. parser init, we need to pass parser JSON C JSON parser in C and the version. Okay, we'll probably need the result. I think init always works. Nice. Parser free. Okay, and yeah, in my ds.h library I also have this return defer macro, which just does the go to defer and sets the result to the status code that you send. So it's like a neat little like, you know how Go does it, but it's more verbose in a way. Okay, so let's do argparse. Well, I thought it's, yeah, add argument. So let's do should have this one something like this, and now we can have all of these fields. Right, so we can use a short name, but this is like the input file. Right, but these are not really important because it's gonna be a positional argument. So description input file, and the type should be something like argument type positional, and required is gonna be actually required is gonna be false, because if the argument is missing, then we can just read from standard input. Okay, so this one can fail. Yeah, it can fail. So if this thing is not equal to 0, which is the OK status code, could not argument input, let's just say, and then we can return defer 1 or -1, something different than 0. Okay, so next up we can just parse the arguments. So that's done using argparse. Actually I forgot, it's called parse. Yeah, should be called parse. So we have to pass all of these, and yeah, this thing also has a return, so we can do the same thing. It's not 0, then could not parse arguments. So it's like based on how you specify these arguments here, it's gonna run a validation, and if that's not correct, then you just fail. return defer1. Okay, and then if the parser has stuff allocated, it should just free the stuff. Okay, and now to get the name, so file name, let's say I'll parse get value, and we just say input, which is the name that we set here. Oh, and we also need to send the parser. Right, and I think that we get a reference, so it's gonna be, yeah, we don't even need to allocate anything. I mean, we can just print f %s file name, right? And if we run main example JSON, is gonna give us the name, and if we don't, it's gonna segmentation false because yeah, we try to print null and that's not gonna work. Anyway, yeah, and we can also see it here. So if we now use a read file, we should be able to say file name, and here probably buffer. Let's define all of those here. Char pointer file name, char pointer buffer, so that we have them. And yeah, this IO read file is gonna allocate buffer for us, so that's why it's a double pointer. Okay, this should also give us the number of bytes read. Okay, should be an integer here. So let's do buffer len, and buffer len is equal to that if buffer len is smaller than 0. I guess 0 is still fine, but yeah. So if we read 0, then this log error could not read from file. And could be something like this. And then for the file name, we can even just say file name is equal to null, and if it's equal to null, then we can just say std in, otherwise file name. Like, I'd say it's fine if you use the ternary operator like this. Right, I'm too lazy to create a variable, so just do that. Okay, and now buffer actually needs to be freed here. So let's handle all the memory allocations, shall we? Like, it's gonna be free buffer. Oh, and instead of free, I have this ds free. What do you mean it's not defined? Okay, yeah, and ds free actually uses the allocator as the first argument. And if you see here, if the allocator implementation is included in the code, you actually get the allocator free and allocator whatever. So yeah, if we check out IO read, this is memset and stuff. Oh, it uses the string builder, so it's gonna use, oh, here it's build, right? And build uses dsmalloc, so it uses the one with the, oh, that's sad. I should have used here the allocator from the items, right? Like this should use the allocator, but you know, it's beyond the point of this one. All right, so in make example JSON, it ran without any issues. So if we printf the buffer, we should see our JSON. That's pretty cool. Okay. So I guess from now on we should start with the Lexer, with the actual Lexer. So the point would be trying to build this data structure. So let's say we are gonna have something like JSON Lexer init, right? And here obviously it's gonna be the Lexer, the buffer, and the buffer len, right? This thing should probably, I mean, it's not going to have any errors because it's going to be just initializing the buffer and buffer len. So that's first thing. And then we might, I mean, the cool way of doing it is probably going to have something like JSON Lexer next. You pass the Lexer and maybe a token, or it could return a token actually. Like we have two options. We can either take it like this and it's going to return a status code, but Lexer, like if you implement a Lexer, you know, you should keep in mind that the Lexer should never fail. Like the Lexer part of a parser should never display any errors. It should just give you the tokens even if they are like invalid tokens. It should just finish without any errors. So that's also something else, right? But yeah, I mean I'm not really sure if I don't see why we cannot just return it, but at the same time this one looks better in my opinion, to have the output as a pointer. But yeah, I mean it is what it is. And at the end obviously we'll have something like JSON Lexer free or something, and we just free the Lexer, which actually these should be in the reverse order if you think about it. Like the differ list I think it should be like a stack. So the last thing you added should be freed first. But I mean, freeing the Lexer won't do anything pretty much. Like, probably it's just going to set the buffer to null and the buffer length to 0 so that you cannot use the Lexer anymore. That's something. And actually this thing frees the bytes that we read from the file. So this is just gonna be because I think each init should also have a free function. You know, just in case you decide to malloc something in the init, it's better to have it like this. And following the same logic, I guess each init should also return a status code, but even if it's always 0, like unreachable code, let's say. Anyway, so let's try to implement these functions, right? So I guess the next is also going to be in a while loop. All right, I don't know if I want to have a while 1 or what. Like at this point, this would be cool. While next, right? And now it makes sense for this one to return a 1 when we have a token, and to return a 0 when we reached end of file. See, like now it makes sense for that. Okay, so let's have the JSON Lexer data structure. So type def struct JSON Lexer. Okay, and now let's define these functions. So okay, let's make it an integer so that we have something. JSON Lexer pointer. This should be a char pointer, and I can make this one unsigned int buffering, probably const char. Okay. Okay, I said this one should be an integer. So we return 0 when we are done. It makes somewhat sense. And here we need another data structure called probably JSON token. And let's also copy the void thingy. Okay. So let's have JSON token, and I guess that compared to my last, the compiler stuff, I'm gonna do everything in the main.c file. I'm not gonna split stuff into different files because I'm curious to see how big it's gonna get. And yeah, I mean, if you think about it, splitting your project into multiple files was, I guess, invented only because like VS Code cannot handle more than 1000 lines. If we think about it, like it is what it is. But I'm pretty sure that Vim can handle. So if we look at ds.h, oh, actually it's quite funny. I mean, the LSP works, like it doesn't have any issues with really big files. but I was checking, I think, GitHub Copilot back when it was useful. I don't know, like I stopped using it because I feel it's really bad nowadays, but it is what it is. And I was trying to use it, like I think I pasted this this stuff somehow. What the fuck? Anyway, yeah, I think I just pressed something on the keyboard. Anyway, so yeah, I was actually using it for the IO implementation, and you can see like this function, this IO read file, is really far away from its definition, and it wasn't able to build, the context. So I guess the context for GitHub Copilot is around 2000 lines of code. Depends how many tokens it was actually reading, but yeah, it couldn't figure out these headers. So the difference is like 2000 lines. So I'd say that's the limit for Copilot. Yeah, anyway, let's get into the more interesting stuff actually. So let's see, let's define the Lexer just to have it here. So JSON Lexer I can say is equal to 0, and token should also be created here probably. All right, so now we have the main logic for our Lexer. It's going to initialize it from the buffer, and then we are just going to read each token. And I think that probably the main thing is going to be storing the tokens into a list, like that makes sense, but we can also just print them. But yeah, for now we need a way of having tokens actually. So type def struct JSON token kind. It's actually an enum if I think about it. So yeah, JSON token kind, and we have something like, should I say JSON token? If we take a look at example JSON, we can have like L brace, right? JSON token R brace, JSON token colon, probably comma, then JSON token, this is like a string, right? Oh, and with L brace and R brace, it's also JSON token. Wait, braces are the squarely ones. Yeah, squarely. Wait, I don't know how to type this shit. Square. Okay, strange. Right, because I think that you call like a bracket this one, and this is like a squirrely bracket, but I don't like that. The name is too annoying. I'm gonna do squirrely like this. SQRLY. Yeah, I don't even know, like I wasn't in this position of having both squirrely braces and like these angle braces. All my languages had either one or the other, never both. But yeah, like strings, we are not gonna split, like the quotation won't be a separate token. The entire string will be a token because we can have these weird escaped strings, right? So if we think about these, we want this entire thing to be a token. That's gonna be the interesting part. Okay, then we have JSON token number, and I think that for numbers we can have a single kind even if it's a float or an integer. Although, I mean, I was just thinking about JavaScript doing it, so then we can, I guess we can have int and float. Oh, and the other thing is, in example, let's have alive true. We can also have booleans. Integer, float, boolean, and string. And obviously null, and the file, and my favorite illegal, which you know, if you have is equal to $sign, that's not a thing. So, or is it? I don't think it is. Yeah, anyway, so let's yeah, basically we have all of these, right? And now besides the kind, we want a union. And in this union, we want to say stuff like, okay, for the L braces and squirrely braces, we cannot have anything, or for commas, but for strings, we can have a char pointer string. Is it like that? I think, yeah. Then for integer, we can have like that, right? Then float, we can just say real number. Okay, then we have boolean, which is gonna be, I mean, we don't have bool. Oh, let's actually type def boolean. So type def bool int is the other way around. So we have somehow boolean. Let's say boolean. Then null again, it's not important because it doesn't have a value. End of files, the same thing. And illegal might be interesting. is gonna be a character illegal. I think that's how I want to do it. Yeah, I guess so. I mean, you can have a string which is illegal, but yeah. Oh, but actually, you know what I realized? This union should actually be saved for the AST tokens. So actually for our JSON tokens from the Lexer, we are just gonna, because here we also like interpret numbers and stuff, like that's not really, because if you interpret a number, you can get an error, right? So we don't want to handle errors in the Lexer, as I said. So let's just keep a char pointer for the value, and maybe unsigned integer for the position in the buffer. I think these are like, this could be useful. Okay, so now for the Lexer itself, obviously it's gonna need char pointer buffer. It's also going to need the length, let's say unsigned int buffer length. Let's say constant char, yeah. Even here, I guess I can say constant char pointer. Yeah, anyway. Then how I started to do the Lexer is usually by having to, oh yeah, the two numbers. So one would be a read position. So yeah, the read position, the current position, and the chart that we are currently on. I know it's a bit weird. So unsigned int position, signed read position, and char ch. But yeah, the idea would be that we have, even though we can just use one of them, I don't know, I just learned it like this and I just kept going with it. And even char, you can just take it from the buffer, but yeah, I don't know. Okay, so next up we need some private functions, let's call them, for our JSON Lexer. And these functions are gonna be, advancing the Lexer and reading the Lexer, something like that. So yeah, usually call them pick and read. And let's see, so the pick function, JSON Lexer pick, I'm gonna do it like static just to indicate that it's private. JSON Lexer pointer Lexer, right? And so the idea is that if our read position, so Lexer read position, is greater or equal than the buffer length, we should return end of file character, because we are outside of the buffer basically. And otherwise we want to return a Lexer arrow buffer, and the position is actually read position because we are inbounds, let's say. And the next function is going to be still returning a char. JSON Lexer read. And this function, besides returning the current character, is also going to skip the next character. So first we do something like Lexer arrow ch is equal to JSON Lexer peak. So we just read the current character. And then we do something like position is equal to Lexer read position, and the read position is advanced by 1, and we return Lexer ch. So yeah, like the difference between these two is that this one just returns the current character, and this one stores that character and moves to the next step. So yeah, it's gonna help us with look ahead tokens and stuff like that. So let's do something that will help us maybe better understand this pattern. Maybe something like JSON Lexer skip white space, because we are gonna need it anyways, so why not? So we can do something like while is space. We need C type for this. Yeah. While is space, and here we pass Lexer ch. I think it's equal to 1 if it's space. Well, if it's space, then we can just Lexer read. So we just move to the next character, and here we check if that character is space or not. And that's how we skip white space. Yeah, I mean, I don't know, I think it's okay-ish as the implementation. So let's go ahead and do Lexer init first. And yeah, I guess for Lexer init we want to set buffer to buffer, buffer len to buffer len. Then we have this pause, read position, Lexer ch like 0, and to initialize all of the stuff you can just do Lexer read Lexer. So we basically just initialize our Lexer with these values, and then we call Lexer read once. So we initialize our current character and set the read position on the first, I guess it's no longer the first one, but it's the second character, right? So we are ready to pick the Lexer, and we also have the current character. So that would be the idea. Okay, I mean, hopefully it kind of makes sense. Yeah. Okay, and now reading the next token. This is gonna be the interesting function. So reading the next token, I guess the first step obviously is gonna be to skip the white spaces to use our helper function. So let's just copy it into here. So we just skip white spaces. And now I think we just need a really big if statement. So let's do if Lexer arrow ch is in the file, right? Like that's the first case. How did I call JSON token EOF. Okay. So yeah, like if the current character, we can just do Lexer read every time. So we skip that character, and then, oh, I said, now this is gonna be interesting. Like it makes sense. If I do pointer token is equal to JSON token like this, and then I say stuff like kind value position, right? Kind value and position. So kind is equal to JSON token end of file. Value is gonna be null, and then position. See here we change the position in Lexer read. So let's save the position before the if case. Position, and now we can do position. Okay. Oh, and yeah, I said that next is gonna return 0 when we need to stop. So that's gonna mean return 0 here. I guess it's fine. I was debating between using JSON token as a argument or as the return type, but I think that if we continue with having this while loop here, it's gonna be nicer to return it like this. Okay, I mean, otherwise we can just do a do while loop. That's also an option. But I think this one is also like a decent approach. Let's see if it's gonna work. So yeah, we read the current character, we set I mean, actually I kind of don't like it because I don't know, I feel like it should just return a JSON token instead of doing it like that. So like this, right? It feels a bit better if I just return the JSON token. So it's gonna have an else that catches all the illegal tokens. Okay, let's go here. So we don't need a token anymore. And how I'm gonna do this one, as I said, probably is gonna be a do while loop. Do while something like this, and here token dot kind is not equal to JSON token in the file. But I don't think I can. Yeah, I need to define it. I mean, it was fine. JSON. I should just define it here. So yeah, like this is the same thing, kind of. So we do a JSON Lexer next. We read the next token, and if it's an end of file, we stop. So do while this thing is not end of file. All right, so yeah, we get all the tokens. I mean, that's, yeah, kind of. Return, let's do the else case when it's gonna be, I mean, I guess not. Let's do else if, and to be honest, what would it look like if I do? Let's do L brace, R brace, all of those easy things. So if we have our squirrely, obviously we have to Lexer read. Oh, nice catch. Yeah, that's why some people like to do, instead of comparing it like this, they like to compare it, let's, like this, because this one is an error, while this one is just a warning, right? So that makes sense. So yeah, if we have the squirrely, I mean, I still don't like the name, but it's better to have it shorter. Okay, let's do the right squirrely, and obviously the braces now. So for arrays, L brace, R brace, and for the value I'm gonna keep it null because we know it's gonna be like this character, so I don't care about it. We still have colon, comma, and then are the interesting ones. Colon, comma, yeah. Let's copy this stuff. So if it's equal to colon or comma. Right, we don't care about the values either. But now for string, integer, float, boolean, null, we kind of care about them. We can do null and boolean first because those are gonna be easiest. Right, so the idea is, yeah, I mean, instead of doing just a comparison, we're gonna do something like is lowercase Lexer ch, but at the same time, let's just check in example JSON, how would it handle hello? Oh, so it's just a string then, or is it? No, it's, I mean, let me just install JQ and I'll test it, what this does. Okay, so if I cut example JSON into JQ, invalid numeric literal. So it's like a parser or not a Lexer error. Column 19, so at the end of it. Okay, so it tries to parse it as a number. Interesting. Wait, what? At line 9? Ah, sure, because of that. Yeah, I mean the JSON way of doing it. Okay. So that means that's interesting, because if I look at that, it somehow tells me that you have only one kind of numbers, numeric, but how does it know it's an integer or a float? I guess that's not gonna be part of our, we are gonna have string, number, boolean, or null. We won't care if it's a float or an integer. We care only if it's a number. And yeah, looks like if we have something like number, like I don't know, like a string there, it's gonna say, okay, it's invalid literal. Yo, that's so weird. Like, how is, that's so weird. Huh. I mean, yeah, I don't know. I guess it bases itself on some like hexadecimal or something, and if it's not in hex, like ABCF should be a number, but yeah. I don't know how I'm gonna handle that, but yeah, we'll figure it out. So if it's lowercase, oh, I'm curious, what if I do uppercase? Huh. So, yeah, I mean, my Lexer is gonna work differently, so it is what it is. So if it's a lowercase character, I would like to continue reading this stuff while we find lowercase characters, but we need a way to store the characters that we read somewhere, and for that we can use a string builder or a string slice, something like that. So yeah, let's do define the SSS implementation. So let's do this string slice. We have a slice, and we can initialize this slice to be, let's say, Lexer buffer plus I guess Lexer position. Len should be probably 0 initially, but I don't think I care about the allocator. Or can we just use a string builder. I guess that's also fine. Okay, I guess, maybe it makes more sense to have a string builder. So let's do this string builder builder init I guess is equal to 0. Init never fails, that's fine, I guess. And then we can do like while is lower Lexer ch. We can yes string builder append character, right? Builder Lexer character, and this thing can fail though, which kind of sucks. Can fail. And afterwards let's do JSON Lexer read. So we have all of that. Then we can just this string builder build, and we need like a value here. So let's do char pointer value null. This one can also fail. Can fail. And I guess that now we should probably have another function that checks if it's true, false, all of that stuff. So yeah, let's do something like static JSON token JSON Lexer literal to token. I mean, I guess something like that. And here should be the literal. And obviously, if we can do with str compare, basically something like string compare literal with null, for example. If it's 0, we can just return. Let me just copy this and just copy JSON token null. Oh, maybe we also need a position though. But I mean, for the position, we can just set it afterwards. So let's just return the kind, right? Okay, and here we have an else. Oh, I could just say else it's a boolean, and otherwise, yeah, let's just say for now that otherwise is gonna be a boolean. And the value is gonna be literal. So like no matter what you put there, you get a literal as a boolean. So if it's not true or false, it's gonna be an error. Okay, and then we can do something like JSON token t is equal to Lexer literal to token, give it the value, then we can say t.pos is equal to position and just return t. Okay, so that's how we handle everything except for numbers. Let's just, oh, everything except numbers and strings. So for now, let's just say that on the else case, let's just imagine that we do JSON token illegal, right? And I guess for this one, yeah, I mean, you can say that string builder has more failures, like failure cases, than string slice, but it's more natural to do it with string slice, to be honest. No, with string builder, sorry. Like string slice could work because you can just take a view into the string and then make it owned, but yeah, probably that's the better approach, to be honest. Like this allocates too much memory, in my opinion. So let's do it here for this one with string slice and see how it feels, and if it's better, then we can just do string slice. So this string slice is equal to, okay, and str should be Lexer buffer plus Lexer position. Len is gonna be 1, and allocator, we don't care about it. So yeah, here we can just say char pointer, it doesn't matter. And then we can just get like char pointer value is equal to null, and then string slice to owned slice. Like now only this one can fail, right? Then we have to read, and here I want to set the value. So yeah, I guess I like more the string slice approach. Okay, but let's try and see what would happen for like some really simple tokens, right? Because we haven't tested this one at all. JSON Lexer free is not implemented. Okay, so let's do JSON Lexer free. JSON Lexer free shouldn't really do anything special. I mean, let's copy it from the init. That's what I would do for free, but just set this one to null and just set this one to 0. So let's run main. Let's have some tokens, maybe true. Oh, I don't print them. Yeah. Let's do a switch over token. Oh, token kind. And we can do stuff like print f. I'm gonna put a t in front of it so that we know it's a token. Okay. So if it's an R brace, then we have the squirreling, colon, comma, boolean, number, string. Right. So we get all of these, then we get, oh, yeah, because it's a semicolon, which is fine, right? Like we get an illegal for semicolon. Then we get this one, a boolean, and end of file. And sure, when it's boolean, we can actually print token.value to see it. Right, and I can do echo, let's do something illegal, then true, space, null. Let's also have, right, so we get all these tokens. Oh, yeah, here I printed that. Okay, so yeah, it knows, then it's an illegal one, then it's this, a null, and end of file. Right. Okay, and what else did I want it to check here? Yeah, for illegal. Token.value. I think that's also decent. Yeah, so the character that's illegal. Yeah, the only issue now for true is that this is considered like boolean, so we need to figure out a way of having this without an error. So maybe identifiers in JSON, that's gonna be the thing. And the other thing is I'll try to figure out, actually, I mean, it's pretty easy here. I just want to use string slices for this one. So yeah, let's do 0. Then here, instead of this stuff, I can just say slice dot len plus 1, and let's just string slice to own. Right, so it's the same thing, but it has less failure points. So yeah, and like because the string already exists, we can just take a view into it, right? That's the idea. But yeah, these two can fail, so we should handle these cases. And yeah, I guess this is the point where returning something else than JSON token might have been a better idea, because what are we gonna do if owning a string fails? Like, that's, I mean, you cannot really recover from that error, so we can just panic because it's out of memory. But yeah, but I think it's fine for now. So yeah, we just have to think about this one, like a better approach to this. maybe making it illegal out of the box if it's like anything else than true or false, right? So maybe adding an extra case here with else if it's true or false, and else we just do illegal with literal. So now if we could get an illegal right there, and here we just, yeah, and if we put capital T, sure, it's gonna be two illegals, but kind of makes sense. Unless we do, where is it? Unless we do here like alphanumeric or is alpha. So if it's any alphabetical character, then it's a single token. Well, I need it in both places. All right, so it's gonna be illegal true. But yeah, I mean, I'm not sure. Maybe I want to keep it lowercase, and if you use the other one, it's bad. Still decent. I mean, we still have to figure out strings and numbers, but I guess I'll leave that for next time because, yeah, I guess I'm running out of time. And yeah, I guess if we didn't spend time with the initial stuff, we might have finished, but still think it's a decent result. So yeah, we can figure out how to parse strings in the next one. So because numbers is going to be pretty easy, hopefully. So yeah, so far we are able to parse some tokens from JSON, and I just end it with a nice example too. Right, so we can just say that, well, some things will work, but for now we don't have this stuff, the quotes, and we also don't have numbers. So that's what we need to figure out next time. And once we have numbers and quotes, we'll be able to tokenize this file. Right, that's gonna be easy. And then building the AST, I think that for JSON it's pretty easy to build an AST. And then yeah, so I guess we'll see next time. So see you.